Hello and welcome back to another video. This video is discussing the severe weather potential for Sunday, June 11th. I'll go over the SPC outlook for background information real quickly. Since the last video I recorded, the Storm Prediction Center has upgraded to an enhanced risk of severe weather from just a little bit east of Little Rock all the way up to Bowling Green, Kentucky and southern Kentucky, and all the way down to Birmingham, Alabama, including places like Huntsville, and Atlanta, Georgia, Chattanooga, and in fact, most of Tennessee today is under the gun for severe weather, with a slight and marginal risk surrounding that enhanced risk. And then back to the west, there could be some additional thunderstorms that develop, and it could have a risk of severe weather. Initially, this is going to be a large hail threat from places like Little Rock up into uh, places like Evansville, Indiana, Bowling Green, Kentucky, Louisville, and all the way up to Cincinnati. And damaging wind threat increasing as storms band together and merge into a line. And that's going to go all the way down to Birmingham, Alabama, and perhaps to parts of southern Mississippi and southern Alabama later this evening. And there could be a small tornado threat. The Storm Prediction Center does have a 2% tornado risk outlined from northern Mississippi, northern Alabama, up into Tennessee and Kentucky. And I think that mainly the tornado threat is going to be in Tennessee and Kentucky, Tennessee and Kentucky. And we'll see why that is here coming up. So if you enjoy this video, leave a like and subscribe, and we'll get started. So I'll start here with the upper air pattern. And here is the map at 300 millibars. We have the main jet stream that is located over Baja, California this morning, and we're left with this enhanced flow around this trough that has developed over the Mississippi Valley. At 500 millibars, we have a shortwave trough that's digging down into the Mississippi Valley over this relatively same areas over here with some enhanced flow rounding the base of this trough. And at 850 millibars, we have a low-level cyclone that is organizing over the same areas with a modestly strengthening low-level jet from about 25 knots to 30, even 35 knots over Louisiana and Arkansas. This is helping to transport warm and moist air northward. And so there are warm and moist air advection. And so on the surface pattern has a surface low pressure that is developed over St. Louis, and that has a cold front that is stretching back through Missouri and into the southern plains. We have a warm front that is situated somewhere bisecting Kentucky, Tennessee, and lifting through North Alabama. And so this is leaving a pretty wide warm sector, and that's typically what we see in June. We have this warm, moist air that's situated over the southeastern United States. And so looking at some of the observational data, I'll show that here real quick. Let's change to the right sector. Hang on. Okay. So we have our surface low that is situated over St. Louis. And I believe this is shifted a little bit to the east in the latest update, but it's situated right here with your cold front that's stretching back through Missouri and through Oklahoma. Here is our warm front. And then we have this range of 60-degree dew points over a pretty wide area over through southern plains and up into the Midwestern United States. And it's going all the way up through the Ohio Valley and the Mid-Atlantic region. So this is a pretty wide real estate to work with for storms, and that's why we have this broad enhanced risk outlined from the Storm Prediction Center. And we even have some 70-degree dew points that were showing up from Arkansas and Tennessee. So the atmosphere is already getting primed up for severe weather. And now we're going to look at some sounding data. Going to take a few soundings from this morning at 7 a.m. We're going to start at Little Rock. And we already have a pretty unstable atmosphere above this warm nose at around 1 kilometer above the ground, and some moderate vertical wind shear. Deep layer shear is at 35 knots, and that's only going to strengthen as we go through the day. So once we get some daytime heating in Little Rock, the atmosphere is going to get pretty unstable. And so we're going to look at Nashville now. And the unstable area is just to the west of Nashville, but it is expected to build up until a stronger forcing arrives. And the same is true for Birmingham. It's not really that unstable yet, but that's going to build up and that's going to change pretty quickly as we go through the day today. So that covers the observational data. Now we're going to look at some forecast soundings for today. And we're going to start over in the same areas. We're going to go to Little Rock, Arkansas at 18Z, which is around 1 p.m. So this is just after lunchtime, and we have a strongly unstable atmosphere throughout the entire column. As expected, with the daytime heating increasing, that's going to really destabilize the atmosphere. With Cape values approaching 2,200 joules per kilogram, that's getting to be pretty strong instability with weak low-level wind shear and strong mid to upper level instability. And so that's going to favor large hail initially. So I think large hail is going to be the predominant threat as storms just start to fire up. And then the damaging wind potential is going to increase as we go through the day. And then we're going to look at Nashville here. And this is where things could get a little interesting. This sounding here could show an all hazards threat, meaning damaging winds, large hail, and even the potential for a tornado. And I'll go into why that is. So we have at least moderate instability that's building up here in Nashville, and so we have plenty of instability in this column. But we also have some turning in the wind direction. So we have winds out of the southwest here at the surface, and then winds more out of the west-southwest and about 3 kilometers up, and then winds in the west-southwesterly flow kind of goes all the way up through the atmosphere. So this does create a little bit of curvature in our hodograph here, and so that may be just enough. And sometimes when we have strong instability, sometimes you don't really need a whole lot of wind shear. Sometimes you don't really need some really strong wind shear to get a tornado. Sometimes just marginal low-level wind shear can be just enough to get a tornado. And so that's just something to be aware of up in Tennessee and Kentucky. I think there might be a small chance of a tornado up in there. But otherwise, this is certainly supportive for a damaging wind and large hail threat early on for storms. And so next we're going to go to Huntsville, Alabama. And we're going to advance a few hours here. I'm going to go to around 5 p.m. this evening. And so this is also showing a pretty unstable environment with Cape values approaching 2,500 joules per kilogram. So that's a pretty strong instability. And strong low-level instability, that's going to favor a damaging wind threat. And also instability throughout the entire column and weak low-level wind shear that will also favor some large hail. So we could get some hail in any storms that develop ahead of storms that merge into a line. But once the band of storms is coming through, damaging winds is going to become the predominant threat. So now that we've discussed the environmental setup, now let's look into the timing for these storms. We're going to look at a couple of different high-resolution models. And this is just a simulated reflectivity, so radar may not look exactly like this. This just gives us an idea or a guideline of how storms might behave today. So around 2 o'clock, around 1 or 2 o'clock, just after lunchtime, storms will be developing around Tennessee and Kentucky and stretching back into Arkansas as well. The storms in Arkansas will probably just have a large hail and damaging wind threat. And then storms up in Tennessee and Kentucky may have the potential to rotate. So there could be a low-end tornado threat like we've discussed. And so as we go through the afternoon, this is 3 o'clock, 4 o'clock, 5 o'clock, storms are knocking on our doorstep in North Alabama. They are already merging into a line as they travel to the southeast. And so that by that point, I think damaging winds will be the predominant threat. And again, storm radar may not look exactly like this by the time storms get here. This just gives us an idea of what to expect. So storms push through North Alabama sometime between 4 or 5 through 7 p.m. and then getting down to around Birmingham, Alabama sometime after 8 o'clock, most likely. And then storms will probably weaken and be winding down as we lose daytime heating through the early evening hours. So that's one idea from one of our high resolution models. Let's look at another one and see if we have consistency between the models. And so we'll fast forward here to around 2 p.m. Storms are first developing around 1 or 2 p.m. in relatively the same areas that the other model was showing. And so storms on this model are a little bit slower, but relatively the same idea. Storms are merging together into a line around 4 or 5 p.m. and then moving into North Alabama sometime after 4 o'clock. And then moving through North Alabama, maybe all the way through about 7 or 8 p.m. And then moving through Birmingham sometime around 8 or 9 p.m. And then storms still continuing all the way through southern Mississippi and southern Alabama, which is why the Storm Prediction Center is probably why the Storm Prediction Center is drawing those outlooks all the way down to the south. So that's basically the general idea for today. It's not really a major threat of severe weather, but it is something we should be aware of. And so damaging winds and large hail is going to be the primary threat. Storms will move into North Alabama sometime after 4 p.m. and move through North Alabama between 4 and we'll call it between 4 and 8 p.m. today. So that's going to cover it for today. Thanks for watching, and I'll see you in the next video.